Notes are short and sweet today. We're doing day 2 of finding arc measures. Today's more focused on not the mathematical side like we did on, would that have been Tuesday, where we're adding, subtracting to find like the degree measurement of major arcs and minor arcs. Now what we have is just kind of more with some theorems saying whether or not two arc measurements are congruent. So first theorem, congruent circles theorem, theorem 10.3. It says that two circles are congruent, so meaning they're equal or the same, if and only if they have the same radius. So if you have two circles that have the same radius of length x, they're congruent. So the definition of a radius is a segment that goes from the center of the circle to any point along the outside. So we have radius AC and radius DB. The plural of radius is radii. So those are two radii. And then it says, this what you would read as circle A is congruent to circle B if and only if the radius of circle A is congruent to the radius of circle B. If that's true, circles are congruent. Moving to talk about central angles. A central angle is how we form those major or minor arcs. It is an angle whose vertex is the center of the circles. The definition of what a central angle is. So if you have one circle or two congruent circles, two minor arcs are those arcs that are less than 180 degrees, are congruent if and only if their corresponding central angles are congruent. So in our diagram here, we have arc BC and arc ED, both made with a central angle with the vertex of A. And it says that, well, angle CAB is congruent to angle DAE. So if those are congruent, then these two arcs are congruent as well. So you'd read this as arc BC is congruent to arc DE if and only if the central angle BAC is congruent to the central angle DAE. And then the last theorem I just put on there, just because I think it's funny that it's so short, and they actually take time to say, hey, this is a theorem you should remember. But it's just all circles are similar. So think about when we think similar, we can have similar triangles, which means we had a triangle and we expanded it or shrunk it. Same thing with the circle. A circle is always going to look the same. All right, a circle is a circle. You can have different forms of a circle. So whether you shrink it, expand it, all circles are similar, or they're all proportional to each other. I think that takes the cake as our shortest theorem of the year. I don't think anything's going to top that. So, just 3 quick examples on the bottom now. We're going to go through and tell whether the arcs are congruent and just give a brief explanation why or why not. So the first one we're looking at is arc CD and arc EF, which is CD and EF here. We can notice that they're both in the same circle. And they both have a central angle of 80 degrees. So then, yes, these two are congruent. And then ways you could explain this, you could just state the theorem directly. We could say, yes, I just used the 10.4 theorem. Or you could go back and say that you want to kind of express your reasoning as this. You could say angle CBA is congruent to angle FBE. All right, CBD, not CBA, CBD. Shoot. Not like the thing that you take though, but the angle. CBD, and then FBE be our other one. Those two angles are congruent, so then you could say so arc CD is congruent to arc EF or FE. Just a little short and sweet justification as to why. In the next example, we have concentric circles. Those are termed for a circle inside another circle. So these two circles are similar, but they're not congruent, right? Because think of if I expanded this circle out so it was the same size, or a radius was the same width, radius was the same length, then they would be congruent. But since this is shrunken down, the radius QS is not equal to the radius QU. So these are both, if you want to put, this is a radius, and this is a radius. So if our two radiuses are not equal to each other, then we say, nope, this is not a not congruent circle. So we'd say no. Say the radii are not equal. You could also say it fails the first theorem. It breaks the first theorem where it says, well, circles are only congruent if the radii are equal. Well, these are not the same. Oh, they're not equal. Very last piece. Again, we have two circles in the same plane, and we're trying to find if UV, arc UV and arc YZ are similar. So they both are made up a central angle, this being with the vertex at T, this at a vertex at X. So our central angles are congruent. Our radii are also congruent. So yes, they are congruent, and you could say for a lot of reasons, you could say we want to do the angle one again, but let's use, since we said, okay, radiuses are not equal in this one, let's say prove it by using yes, the radiuses are equal. So you could say segment TV is congruent to segment XZ. So our circles are congruent. So circle T is congruent to circle X. And if the two circles are congruent and they have the same central angle, go say angle UTV is congruent to angle ZXY. So again, UV is congruent to YZ. So why this one took, we had more justification here, because I first had to prove or show that these two circles are congruent to each other. If they're congruent, then I can use the other theorem. So first we use theorem 10.3 to prove that it's congruent. And then we use 10.4 to prove that our arc lengths are congruent. So the homework today is a mix of this and what we did on Tuesday with